Hi there, I'm Dr. Nate Storey from Bright Agritech, and this is Aquaponics Academy episode number 12. Today we're going to talk about aquaponic fish production, more specifically fish production techniques, what types of fish tanks exist, what people use for tanks, stocking densities, and some of the other issues surrounding fish production in aquaponic systems.
Welcome to Aquaponics Academy, a Bright Agrotech podcast designed to help you overcome common aquaponic issues, learn new growing techniques, and help you be as successful as you can be as an aquaponic practitioner. Join aquaponics expert Dr. Nate Storey, the creator of Zip Grow Towers, as he breaks down complex topics into easy-to-understand information. And now, here's Dr. Nate Storey.
Today we're going to talk about all fish production. We're going to cover fish production techniques, fish tanks, aeration, circulation, stocking densities, all that stuff. And we're going to talk about how we've done it in the past and also kind of how a lot of our friends do it. But before we jump in, I want to throw out the caveat that plant production is my thing. Fish production is not. So the reason this podcast is relatively brief and the reason we're not going to spend an awful lot of time on fish production is I really don't like talking about things that I don't consider myself a complete expert on. So with that caveat thrown out there, let's chat a little bit about fish production in aquaponic systems. There are a lot of production techniques out there for fish in traditional aquaculture. This has been everything from nets and cages and open water to ponds, man-made dugout ponds for catfish production in the South. Up to poly tanks, similar to what are commonly used in aquaponic systems. So there's a lot of techniques out there for holding fish, feeding fish, managing fish, and a lot of it has been centered around the traditional aquaculture industry. This is an industry where they're growing a lot of fish and not a whole lot of space. If it's in a recirculating system, something like that, or it's a more traditional outdoor system where they're raising fish in cages, in lakes or in rivers or in the ocean, or in ponds. These are man-made, basically ponds that are dug out, and they fill them with water, and they fill them with fry, and they feed the fish out, and then they drain the ponds and haul the fish away. In those types of scenarios, the stocking densities aren't as high. But as soon as we start talking about putting fish in tanks and housing them indoors, you start to see stocking density. That's the number of fish per gallon of water, or the pounds of fish per gallon of water, start to rise. And the reason for that is that real estate is not cheap, right? So if we're going to pack these fish in and we're going to spend a lot of money on filtration equipment and all of the other things that are necessary to keep these fish alive, we want to grow out as much fish per gallon as we possibly can. So there's all sorts of techniques out there. The most common ones to aquaponic growers are basically using tanks, right? These are poly tanks or metal tanks or liner-based tanks. And these are typically above ground. Some folks do them in ground. Doesn't really matter one way or another. But yeah, this is how most aquaponic folks do it. And it's interesting because this technique was really pioneered in aquaculture by folks doing what's called recirculating aquaculture systems. Before recirculating systems, water would just dump into the tanks and you'd grow your fish, and as the fish were growing and metabolizing protein and all this stuff in the feed, and they're releasing all these toxins and they're pooping, all that water would just be flushed out. So you just basically flush it right out, dump it somewhere, put it in the sewer system, irrigate with it, get rid of it. And you dump in nice fresh water. Well, that works really well when you've got lots of water, but when you don't have a ton of water, it can be pretty wasteful. So people started focusing on recirculating. That is, taking most of the water in the system, filtering it, running it through different pieces of equipment to remove, say, carbon dioxide and to oxidize ammonia, and to kind of do all of this work to get the water back to the point where it could be sent back to the fish and the fish could survive in it. That was recirculating aquaculture, and aquaponics folks just basically took that idea and said, hey, wouldn't it be great if we could eliminate a lot of this really expensive equipment by using plants? what if we just made biofilters and we use plants and to remove all of these toxic things, to remove all this waste, and we could get the best of both worlds. We could have fish and plants. And so that was really kind of the seed for modern aquaponics right there. It came from recirculating aquaculture. So we owe recirculating aquaculture folks a lot because they did a great deal of research before we ever came around. So there's all sorts of containers out there, and the most popular ones are typically tanks. Now, we tend to use poly tanks. We like poly tanks. They're very expensive, I won't lie, and they're usually on steel stands the way we use them, so they're above ground. They're easy to access, easy to get to plumbing, easy to replumb and fix and do all that stuff. It's one of the reasons we really like them, but they are expensive. A lot of other folks have used things like stock tanks, and we've used stock tanks in the past. You know, the big thing there is galvanized steel will kill your fish. Zinc is really toxic to fish. So if you're going to use something like a stock tank, you have to coat it with an epoxy paint, or you have to coat it, use a liner in that tank to basically separate the fish from the zinc, or what galvanizes that steel. So those are the most common tanks, are liner stock tanks or tanks really meant for other purposes that are just kind of repurposed for aquaculture or fish production. Then you have tanks that use liners, okay, to seal them. These can be plywood tanks you build from plywood. And then, of course, you have poly tanks. And there are lots of other tanks out there. There's cement tanks and in-ground tanks and all sorts of other things, steel. But they're not common enough that we're going to really dig into them. And there is a lot of research out there on the commercial side with all sorts of interesting new raceway designs for raising fish. So definitely look into that. Do a little research because there's some great stuff out there, and there's only more interesting things coming to market. So there's all sorts of tanks out there, and the big purposes that tank serves are to hold the fish, hold the water, right? They have to allow that water to be circulated in some way through the system and also within the tank. And they have to enable some type of management. So they have to enable you to manage the fish, whether it's by size, by weight, by fish type. They have to allow you to manage solids. So using something like an SLO, and I'll talk about that a little bit later, a solids lifting overflow, to basically remove solids from the tank. You can design your tank to accommodate these different little devices that you plan on using in your system. And it allows you to just basically manage your fish, problems that arise as a result of the fish, and keep your system healthy and clean and the way it should be. So these are the big things that tanks do for us. And so long as they're providing some of these basic, tank duties, we can use all sorts of different things for tanks, and we can use tanks in lots of different ways. Circulation is a big one, though, and especially in aquaponic systems, because we're taking water from the fish tanks and we're circulating it through our system. We want to make sure that we're enabling the best circulation possible. For us, this means using poly tanks with conical bottoms. And the nice thing about conical bottoms is solids settle down to the bottom, and then our SLOs pick them up off the bottom in the middle of that tank and suck them out of the tank and send them down the road. So circulation is really important. And when you're thinking about tanks, you want to think really carefully about circulation. What kind of circulation do your fish need? Are they fish that tolerate poor water quality? Are you going to be turning your water over a little bit less than you would if you were, say, using trout, which need higher quality water that you need to be turning over a lot more often? These are the questions regarding circulation that you need to be answering when you're thinking about your system and when you're analyzing what tank types to use. Aeration is another one. So tanks need to enable aeration of some sort. Now in our systems, we aerate our tanks with wands. So we basically blast water in from our pump under high pressure through wands that extend out, about halfway across the tank. And that pressurized water blasts out and blasts down and hits the surface of the tank. And it both spins that water, so it circulates the water within the tank, so it introduces flow. But it also introduces a lot of oxygen, because as that high pressure water travels through the air, there's basically some oxygen that's dissolving. And then as we circulate it and as we mix those bubbles into that top layer of water, what oxygen is dissolving into the water and CO2 is coming out of the water, and there's diffusion taking place there. So we use wands for our circulation and our aeration. A lot of other folks will use other things. Folks that are doing a little bit more dense stocking densities will use blowers. So they use blowers to keep air bubbling through the tanks, to keep air bubbling through the system, and keep oxygen, as much oxygen in that water as possible. Now, we'll do a podcast on this later, just on oxygen and how oxygen dissolves and what it does in the water and why it's useful. But you have to keep in mind that the higher the stocking density, the higher the oxygen consumption, which means, the more fish you have, the more oxygen they consume. It's kind of a no-brainer. And similarly, warmer water fish that like warmer water, the thing to remember there is that warm water holds less oxygen than cold water. So when you're thinking about aeration, the more stocking density you have, the more aggressive you have to be about aeration, the more aggressive you have to be about circulation and turning your system volume over more often. So, stocking densities are really the next thing to talk about. In aquaponic systems, of course, we advocate stocking densities of 1 pound to every 8 to 10 gallons of water. That's really low compared to a lot of traditional rates. And even a lot of recirculating aquaculture folks would, they'd think that was kind of funny, honestly, because a lot of the guys that are doing really intensive aquaculture are culturing fish at, up to 1 pound a gallon. And to do that, they have to have really intensive filtration equipment. They're usually injecting oxygen, so pure oxygen directly into solution. So they may not even use bubblers. They're probably just using oxygen diffusers. And they're injecting oxygen directly into their solution to make sure that it stays as saturated or supersaturated as possible. And so this is something that they do to kind of keep their fish alive, to keep their fish healthy when they're growing literally 10 times as much fish per gallon as I do. So, stocking densities are something that you have to remember as an aquaponic producer. You have to run lower densities than recirculating aquaculture. You're not a recirculating aquaculture person. You don't have $1 million worth of filtration. You're probably not removing solids in the exact same way. You're probably not removing solids to the same extent. Which means that you have to run lower stocking densities to make sure that you're keeping your water quality at the level it needs to stay at. So keep that in mind. A lot of folks will look at recirculating aquaculture systems and they'll say, oh, I'm going to run the same densities in my aquaponic system. That's just not going to happen. And so when people come to me with their business plan and they show me a business plan where they're producing 1 pound of fish for every gallon of water, a 500-gallon tank's going to churn out 500 pounds of fish on a life cycle, on one management schedule, then the first thing I say is, hey, you need to chop this by about 90%. And if you chop it by 90%, that's going to give you a realistic output when it comes to fish in regards to this system. So keep in mind that stocking densities are lower, and keep that in mind when you're looking at your tanks, thinking about your aeration. Because if you're doing regular old, relatively low density aquaponics, you really don't need to be doing, say, oxygen injection. In fact, you can probably get away with less aeration than a lot of people would think. So good things to think about. Tanks are almost always plumbed into aquaponic systems as kind of the uppermost part of the system. So if depending on the type of system that people have installed, tanks are usually at the very top. So they're fairly high in elevation in comparison to everything else. In our systems, we use a split flow, or you've heard them referred to as chop systems, or an old school word is chift pist, CHIFT, and that's constant height in fish tank, pump in sump tank, or chop, or split flow. All of these things basically just describe a system where we have a sump and the pump splits flow and sends half of the flow to the plants and half of the flow to the fish, and everything then drains back to the sump. And these types of systems, they're very popular and becoming more popular. They are the systems, of course, that we advocate because it allows you to put your towers and your fish tanks at the exact same elevation. They can be on the level with each other. And it works really well for not having to build these big, elevation changes between fish and plants. A lot of people just put in a single pump and they'll have it kind of a sequential flow. So all of the water from the fish tanks will drain to plants. All the water will drain to the sump. That's great, but then you have to have kind of these different grades to your system, which is difficult from a management perspective and from a construction perspective. So it's something to be thinking about, keeping in mind as you're thinking about your tanks. What type of a system are you going to put in? Because it can get a lot easier for you plumbing these tanks in if you're using a chop or a split flow system. And we, of course, plumb all of our tanks in, so they flow from our fish tanks to some settlement tanks. They're kind of settlement tanks. They allow most of the heavy solids to settle out. And they drain from our tanks using an SLO, or a solids lifting overflow. And if you are not familiar with solids lifting overflow, we have resources on the blog. We have lots of other resources out there. And there's a lot of actually really, really smart people that have put together great resources, free on YouTube, all over the place, on SLOs, the different type of SLOs, and how to build them. So definitely go check those out. If you're thinking about plumbing in your tank, I would always recommend that you drain your tank with an SLO. And the reason for that is it both sets the height of the tank, so it makes sure that your tank can't drain down to nothing, kill all your fish, but it also pulls from the bottom. So it's like the best of both worlds, with both an overflow pipe and a siphon, without being either, really. So definitely check out SLOs. We plumb them in, and we actually like to plumb our SLO inside of a cleanout system. So we can actually drain our entire fish tank system if we need to with gate valves, and our drainage system to our settlement actually runs partially inside of that cleanout system. So it's kind of a nice little setup. It condenses everything right in the center of the tank for us, and it lets us drain the entire system from the center of the tanks if we want. And also, that's, of course, where water from the tanks drains to our settlement tanks, and from there to our sump tank. As far as introducing flow or introducing water to your tanks, we plumb off of our pump. It runs underground, comes up, we split it a couple times, and of course we have valves on every single wand so that we can moderate the flow to each tank. Now, having valves on all of your incoming plumbing is really important because depending on how you plumb it, I wouldn't count on everything being distributed perfectly evenly. You want to think about worst case scenario. If I've got a lot of flow in this area and not much in the other, what's that going to do? What's it going to look like? And how can I moderate that later? So use valves, and I always say don't use them sparingly if you can afford it. They're definitely worth the money. Similarly, on your drainage, valves are not a bad idea on your drainage either. So on our clean out, because it connects all of our tanks together, we have valves so that we can separate individual tanks. Similarly, on your primary drainage from your tanks to, say, settlement or to your sump tank, make sure you throw in some valves and think about it long and hard. Make sure it's a strategic addition. I can't tell you how important they are. Just this last weekend, a flaw in our design here in our fish house was revealed when one of the windows, plexiglass windows on one of our fish tanks just cracked, and for no good reason, just got old, cracked, and water started leaking out. Well, we had to pull that window and replace it without losing much water if possible. So we basically had to drop pumps in there and move things around because we didn't have a valve to separate it from the tank that was right next to it. And both of them drained to the same sump tank, so water would flow from one to the same settlement tank, sorry. So water would flow from one tank to the settlement, and then it would backflow through the drainage to the tank with the broken window. And this was problematic. I mean, we ended up figuring it out. Noah and I spent Friday night out there pulling windows and replacing them. Not a fun Friday. But, every time something like that happens, it reveals something new. And this time around, it revealed a mistake in the planning stages, or it probably wasn't actually a mistake. It probably occurred to us, and we looked at the budget and said, I don't think we want to drop another $30 on a valve for this tank and the next tank and the next tank and the next tank. That adds up. So we left it out, or we didn't think of it, one of the two, and it wasn't so much fun when the problem surfaced. So think about the problems that could arise, and, think about how you're plumbing it in a way that's scaling your system, so adding more tanks onto it, and dealing with problems is easy and simple. Kind of the last thing to think about here is tank materials. I know I already talked about it a little bit. Galvanized steel is a big no-no. I have used it before with epoxy, so you can cover it with like an industrial epoxy paint. And honestly, once the algae kind of accumulates on that galvanized steel, it mitigates the effects of that zinc in your system. So you're going to have less zinc dissolving. You're going to have, it's less toxic to the fish. But you don't always want to wait. So think about using a liner. And liners, there's all sorts of different types of liners out there, everything from polyethylene to EDPM. You name it, there's all sorts of great materials out there. For the most part, they're safe, but do your research. Soft vinyl is one thing that I would recommend most folks kind of stay away from. It's cheap. A lot of people use them because they make billboards out of soft vinyl, and then when they're done with the billboard, they just throw it away. A lot of people grab those things and use them for tank liners. The thing to keep in mind is that there are some plasticizers in there, and if you don't know where it came from, some of those plasticizers may be heavy metal based, and those can be a little bit dangerous. So something to think about. Make sure you know where you're sourcing your liners from, your paints from, anything that's going to have contact with your water. Make sure there's nothing toxic in it. Make sure it's safe. And of course, if you go the poly tank route, you're probably safe no matter what, because polyethylene is a really, really super safe plastic, and your fish are not going to be encountering anything too crazy in that stuff. But as you're going, just think about your tank materials really carefully. Make sure you're using good stuff. Remember that if it's in your tank, it will be in your water. If it's in your water, it will probably be in your fish, or it will probably be in your plants. So keep that in mind. As we've kind of gone through this, I've kind of explained how we've done it. Of course, there's a lot more detail in our YouTube videos. There's a lot more detail in some of our blog posts. So if you have any questions about how we've plumbed things together, definitely check out some of the other resources out there. I think they'll be really helpful for you. Well, that'll do it for this episode of Aquaponics Academy. Thanks for tuning in, and be sure to download the next episode where we'll talk about system irrigation and plumbing. If you're a regular listener, you know that with every Aquaponics Academy episode, we help you learn new techniques, overcome common obstacles, and grow your aquaponics or hydroponic system. We also introduce thousands of other listeners to really clear, hopefully demystified, and what we think are really valuable resources for beginners to advanced growers, just about anyone on the spectrum. And all these things can be found at our website, brightagritech.com. So make sure you check out brightagritech.com. We're posting more and more resources there, and hopefully it's growing into an ecosystem that is useful and valuable to anyone that comes across it. If you do find these podcasts valuable, please consider leaving a tip on our podcast website to help us continue producing these. It's not always easy to carve out the time to come in here and record these things, and it's just becoming a lot harder, and we're starting to realize that it's actually pretty expensive too. So if you can help support our efforts to do podcasts, that'd be great. If you're not a Bright Agritech customer yet, we'd encourage you to check out our incredible product lines over at zipgrow.com. Check out our towers. Talk about them all the time because they're just the best thing on the market. So if you're serious about doing aquaponics and you're serious about growing some awesome plants in less space, on the sides of your house, in your basement, in your greenhouse, doesn't matter where, check out our website. We've got some awesome products. I happen to have made a lot of them, so I am a little biased, but they're great, great products. Check it out. And we'll catch you next time for another episode of Aquaponics Academy.